Okay, welcome. This is going to be how to calibrate the Cognex 2800 and 3800 cameras that we have in the lab. This is using the newer Insight Vision Suite version 23.3. 24 seems to be the same. I just don't happen to have it loaded on the cameras yet. So the first thing we need to do is get our image set up. So double click on image to get up to the acquire image details. I happen to know from playing with this that my ideal exposure is about 4. So we're going to go with that, and that looks decent. I'm going to force it to autofocus. And it looks like it was already pre-focused, so it didn't change much. That's fine. And so at this point, I can come over here and hit enter and accept those settings.
One thing that you should be aware of is that my calibration card is in fact upside down. You'll notice that the fiducials are pointing down instead of up. The result of this will be that the offsets are going to go down for plus Y instead of up. And so if we rotate that 180 degrees, instead the motion or movement of the target object will match the X and Y of the image.
And so now when I trigger it, I get the same image, which is good. I then need to go to functions down here, tab at the bottom, coordinate transforms, calibrate grid, double click on that to insert it. It will pop up our detail property sheet to do the nitty-gritty stuff. Double click on region, set your calibration grid area. You want all the squares in the field of view. Press enter to accept it. And we are going to do checkerboard with fiducial. That's already set. We're doing it in millimeters. We already know, because that's what the grid happens to be, the 10 by 10 grid spacing. We can set this to broad distortion, which is going to, as it says here, type of distortion should correct for, and if you read the documentation, broad distortion says that it does everything, or tries to. So we're going to give that a shot and hit calibrate. And tell it OK. And you'll see we get a mean error of 0.636, max error 145. So that's not too bad. I do like that. The lower the mean error, the better off we are. So at this point, we have a calibration. We turn off our grid. You'll see the little green X's at the corners, which is good. We've got our indicator for the origin center, which is good. So yeah, that is all set. Now we can save this. We're going to do a save as just to be safe. Now, when you're running a job, you don't really need to be doing this calibration every time. And from what I understand of the documentation, I can use this calibration in other scenarios as long as the camera hasn't moved. Things like that. So I'm going to call this KB calibration so that I can save it. I am also going to copy the calibration information here. You know what? I'm actually going to copy all of it just to be safe. So we're going to copy that. We're going to create a new job. Yes. And I am going to stick this calibration over here. So it's out of the way, but it's available. I'm going to move it later. All right. So at this point, I need to swap out what my camera sees. So I'm going to go put the actual part we're going to be tracking into the field of view. Okay, so I've placed my part underneath the camera. because we are in a new job, you'll notice that our image is not, we don't have an image. So we're going to set our exposure to the 4 milliseconds that we talked about earlier. So we got, you can see in the background our image here. Let's see. Our trigger source for our purposes is actually going to be, factory protocol, so we'll just leave that one on. The debounce, we don't need to really worry about that because we're doing a digital trigger through software and not a mechanical one, but that's fine. Let's see, our exposure hasn't changed, that's still good, and we're not going to do an offset. We don't need to do any kind of gain. We're going to leave the lighting the way it is. And so at this point, we should be set. We can do autofocus again if we really want to. I doubt it'll change much. And we can accept that. So now, when I trigger, we got an image. And as you can see, it's this black pin. One thing that you will note that I did when I placed that is I did try to get it to about where the origin of the part of the grid was. All right, so we can comment with text in here if we want to. So I can come in and type capture part. And so what we will be doing under functions, a couple ways we can do this. Two options we have to do this are we can do it as a blob or we can do it as a pattern match. In the past, I always did this as a pattern match. It seemed to work real well with the Easy Builder interface. Trying to do the pattern match with this is a little bit more challenging, but that's okay. We can go to pattern match, and what happens is we have to train it. And so we can tell it to train, and we're going to say our image is fine. We're going to go to a pattern region, double click. We're going to select what the pattern needs to look like. Press enter, and we can train it. Tell it okay, and you'll notice now we got a center on it and green outline, so we have a good part. That has only trained it. It has not actually found it. To find it, we need to do this find Pat Max red line. And so again, this is one of those things, this pattern, we actually don't need to keep it there. I'm going to move it over here, paste, and I'm going to put my find under the capture. And the find region is going to be everything. We want this piece of white paper is just there because the wood is not the best for the contrast. So that's that. We are going to tell it that the pattern is this. And we're only going to look for one at the moment. Everything else probably will be fine. We're going to do show all just to make sure we know we can visually see what's going on when we test it. And you'll see that it found a pattern. It found it at this location. So on and so forth. Now, normally it'll say X, Y, some other things. I think because I put this where I put it, it blocked that. So to find the pattern after creating the patterns, okay, so we've found our pattern. I want to move this out of the way because, like the calibration, it does not have to be part of the regular job. And so to actually find the pattern, we actually do the find. So that was training. Whoops, cancel, no. Put our cursor back in the right location. And we're going to tell the region to be the entire screen, basically, or at least in our case, the entire piece of paper. Paper is just there to give us some contrast. Our pattern is going to be from here, and everything else is good. We're going to show the results just to make it easier. And so it's saying, hey, I found one item because the index is 0, starts 0. Here's my XY location, my angle, my scale, my score. So that's what it's found. Here's where it gets tricky. So after we find our captured part, we then need to convert that part information to real world calibrated data. Because if I send the robot an X of 865, Y of 554, it's going to try to offset that much. And that's going to be a problem because of the reach of the robot and the work envelope, and in our scenario. So those are pixels, those are not millimeters. And the robot wants millimeters. And we could convert it there. It's a little uglier. The camera in Cognex has done a great job here, so we're going to do that here. All right, so we're going to convert, convert location to real world data. All right. And I could go in and change the background colors and do all sorts of fun stuff there. I'm not going to worry too much about it at the moment. So we're going to convert it, and to do that, we have to do the transform patterns to real world. Double click on that, select our calibration, which is here, select our patterns, which is here. Number to convert, we're only doing the one, tell it OK. And the crankiness in me is forcing me to do that. Ignore it. But here's our pattern, and it's at an offset of 1.3 millimeters, 8.01 millimeters, which is realistic. I'm sure I did not get it exactly on the origin. That's fine. This is how far off it thinks it is. All right. Next step. All right. So we've got our pattern. We need to move this into a buffer. And so let's do this. To buffer for transmission, and that falls under input output. It goes under format output buffer, so we can tell it what we want to add, and we want it to add the X value, and we want to put it into a 4-byte 32-bit floating point value. That's good. And then we're going to do the Y value. We tell it that that's okay, so that's good. And so we've now placed these two items in the buffer for writing in that sequence. And it's important to know which sequence you place those values, because the robot or whatever, the PLC, whatever, is looking for them in specific locations. And so I am going to put a note here that says X first, Y second, just so I can remember that. And then I'm going to write the buffer. Okay, so we're going to write the buffer, and it's write results buffer. And so this is fine, this is fine. Buffer is going to be the buffer we created. The protocol needs to be, the protocol needs to be Ethernet IP, and the default is fine. So go write results. And so now if we were to trigger this and run this and look at the results in the PLC, we would see this X and this Y value appear. And so let's go switch over to RS Logic Studio 5000, and we can see that in a moment. All right, so my PLC is all set up. We're going to ignore that, how that works, how that's configured, but suffice to say that I'm connected to the camera. I'm not connected to my robot at the moment. That's fine. Here is where we are going to see the X and the Y come in, and then for various reasons, I've got some other activities going on that convert the data and put it into an array in a FIFO array for smoothing. So I'm doing a running average basically. So we're going to save our job first. I suppose it's always a good idea. Let's call this and we're going to place this in, let's adjust that a little so we can see the background a little bit better. And we're going to set that online. Okay, so we're going to trigger the camera. Remember when we set this up to use the industrial protocol. So when I do trigger here, you'll notice that the value in the buffer up there changes. But also, we now have an X value of 1.264111. If we look at Insight, X is 1.264. So this is only showing 3 decimal places, whereas our PLC has more, but that's fine. If we look at the Y value, the Y array as well as the X array here, we can see the same type of results. There it goes. 7.960, 7.960. So that is how you get the data and the tracking out of the Cognex camera into, in our case, PLC, and then there's a transfer from the PLC to the robot as part of the vision guided side, but that is separate and for a separate video. But as you can see, as we move the part around physically, it is going to update continuously. And if we trigger our camera again, you'll notice we get updated values because the part has moved from where it was to down here. Okay, so off camera, I updated the PLC logic a little. And so now it is triggering every 2 seconds functionally. And you can see here on the results side that these are changing. If we watch here, we'll see our positions changing. And you'll see the, as I move the part, the camera will be changing as well. Or the part in the camera will be changing. So hopefully that has made sense. It's a round part, so we could really ignore the angle information in there, which is why I'm not transmitting it to the PLC, to the robot. So that's all there is for this video. Thanks for watching.